Greetings, I'm Louis Little, and I'd like to continue the discussion of the elementary wave theory. In the introductory video, I spoke of the available states as being actual waves. These elementary waves are like those available states, the difference being simply that particles follow them in the reverse direction. Now, it might be asked, what's the empirical evidence for these waves? Well, I submit the fact that the double slit experiment can only really be explained assuming the waves go in reverse. That already constitutes some evidence. But in fact, I submit we've actually seen these waves fairly directly, at least in one particular experiment. I'm referring to the experiments where one takes an excited atom and puts it inside a small micro cavity. So it has an atom in there that's excited. And it turns out that if the dimensions of the cavity are such that an integral number of wavelengths of the wavelength of the photon that this atom wants to emit, if an integral number does not fit in the cavity, quantum mechanics says that these available states are reflecting back and forth, and there's no intensity and therefore no place for the photon to go, and therefore the atom cannot emit, or does so very slowly. On the other hand, if an integral number of wavelengths does fit, the reflecting back and forth leads to a large intensity, and you get a higher rate of decay of the atom. And this has been observed experimentally. But what are these so-called available states? Are they real or not? There's no midway between. If one says that they're somehow not real, they're just the place where a wave can go, one has a real problem here, because if the wave is coming from the atom, how does it know it's going to fit before it's emitted? And if it's already emitted and finds it doesn't fit, well, what happens? Does it get unemitted backwards in time or something? The only way one can make sense out of this is if the waves are real. And the atom can only emit the particle in response to the stimulation of the waves that are already there. That's the only way to make sense out of this. The waves have to be real. They have to exist. They have to be something. There's no way to account for this experiment without the waves being there and being real. And I submit this is very direct evidence of the existence of the elementary waves.